Here I am with my favorite class, doing the Chapter 5 practice test. As we've learned in Chapter 5, at one point you may have graphed all of these by getting y alone and finding the slope and y-intercept. But since then, we have learned that you can graph equations by using the x and y-intercepts, by using the slope and y-intercept, or by using a point and a slope. So let's see if we can do the easier way. And if you want me to show you the harder way, I can. So on number 1, if I'm going to find the x-intercept, that means when y is 0. So my x-intercept would be 6. So that means it crosses the x-axis at 6. My y-intercept would be 3, because when I solve for y, when x is 0, I get 3. And then I graph a y-intercept of 3. And then I go ahead and connect those. And I get my line that represents this relationship. Somebody in the audience named Grayson said, will you please show me how to do it with if I were to solve for y? And I said, of course.
Yeah, Grayson.
So we're going to go ahead and go x plus 2y equals 6. And we are going to get y alone by subtracting x. We are going to then divide both sides by 2 to get y totally alone. And I get y equals negative 1/2 x plus 3. Because when I divide by 2, first of all, that's a 1, and it's negative 1 over 2x, and then 6 over 2. So then if I graph my y-intercept of 3, it's already there. And if I rise negative 1, run 2, there I am in the line, negative 1, 2, negative 1, 2.
Wow.
So it's the exact same line, just to be able to cross it.
Good job.
Please hold your applause, Aaliyah.
All right.
Number 2, what's our y-intercept? Negative 3, because this is in form y equals mx plus b. What is in the b spot? Negative 3. Not other than graph the y-intercept and rise over run. Rise over run. Okay, calibration's obfuscos, so we're just going to adjust that a little bit. And okay. The third one, we were given a point and a slope because it's in point slope form.
You could graph the slope.
So m is negative 2, and the point that it goes through is opposite of negative 3 is 3, opposite of negative 2 is 2. So I go over to 3 up 2, and if I have a point and a slope, negative 2, 1, negative 2, 1, I can easily graph a line. And there it is.
You could put that in y-intercept form too. Slope intercept form.
Yep, you could. But it's just extra work. But you could. You're absolutely right. And it would be the same line if you did it right. Okay, moving on. Find the x and y intercepts. So let's go ahead and pause. Okay, so now let's continue, shall we?
Yes, we shall.
Now on 4 and 5, we actually need to find the slope and y-intercept. So I want to put it in slope-intercept form because then I can extract the slope and y-intercept. So on this first one, I could subtract 6x from both sides. And I get 9y equals negative 6x plus 27. The reason I put the negative 6x first is to have the x first, just like in slope-intercept form. Divide both sides by 9, and you all know that we need to divide both of those by 9. We can call it looping, and we get negative 2/3 x plus 3. What is the slope? 2/3. What is the y-intercept? Negative 2/3. What is the y-intercept? 3. Okay. And the next one, we need to get y alone, so I could add 12 to both sides. That would be the easiest way to go about it. So I get 3y equals 7x plus 12. I just flip-flop what was on each side, so it matches my slope-intercept form. And then I could just divide both sides by 3, and we get y equals 7/3 x plus 4. Nope. Said 7/3, did not write it, so 7/3 x plus 4. Okay. 6 and 7, we need to find the x and y intercepts, so this goes back to what we did in the very beginning. So let's just reiterate that the reason we are putting this over a number is we're just showing that what happens if you plug in 0. So we'll plug in 0 the old-fashioned way. So if I'm finding the x-intercept, I make y 0. So I'm going to plug in 0 for y, and I get 6x plus 0 equals 24. So 6x equals 24. X is 4. So the x-intercept is 4. Okay, and the y-intercept, we would do the same thing, and I'll show you the shortcut. If x is 0, it makes that 0, so 12y equals 24, y is 2. So you guys seem to be good with that shortcut. Piece of cake, right?
Yummy.
Number 7, my x-intercept is negative 24 divided by negative 5, or 24/5, or I think of it as negative 4 4/5, or positive 4 4/5, excuse me, or 4.8. So either one is right. Actually, all three of them are right. We'll write 4.8. And my y-intercept then would be 8, negative 8. If x is 0, then I get y-intercept is negative 8. And I can graph those, of course, if I wanted. Moving on. So we have number 8 and number 9. On number 8, we have, if I want to write these in slope-intercept form, what do I need?
Point, slope, point.
What do I need?
The slope and the y-intercept.
The slope and the y-intercept. If I want to write these in slope-intercept form, what do I need? Slope and y-intercept, because I need y equals mx plus b, right? So far I have y equals, I have the m, but I don't know what my y-intercept is. Okay? Now, I was working with a student this morning, and she's telling me that she wants to put it in point-slope form, and so everybody can see that that's actually easier. Okay? Because point-slope form is just y minus my y-coordinate equals m times x minus my x-coordinate. Then I can simply simplify it by distributing. Okay, and I get that. And then I can just add 1 to both sides, and I'm done. Y equals negative 2x plus 9. Is that in slope-intercept form?
Yes.
Yes. What's the slope? Negative 2. Y-intercept?
9.
That's what you're gonna need it.
So we learned this after we had to find the b another way, so now you have 2 ways to find b. We could also plug in that for y, that for x, into y equals mx plus b to find b.
Oh, that's really easy. Yeah.
Okay, number 9. What do we need first? So I have 4 minus negative 2 over negative 16 minus 5. So this is one of the formulas you should have in your toolkit. Slope equals change in y over change in x. And so I get 6 over negative 21. Be careful with those signs. And I can divide out of 3 out of each, and I get 2/7. And it would be negative because a positive divided by a negative is a negative. So now I know it's y equals negative 2/7 x plus b. You guys want to do it the easy way, or you want to do it the b way?
Easy.
Okay, we'll show you the other way that we have learned, and that is just to plug in a point in for x and y. This is saying my y would be negative 2, my x would be 5, and I'm just going to solve for b. So I need to simplify a little bit. Negative 10/7 plus b. I'm going to add 10/7 to both sides. And a lot of you right now are probably saying, ooh, I like the other way better. Yeah. So I add 10/7, and that's fine. That's the beauty of math. You can pick the way that works for you if there's more than one way. And I get b equals, this is 1 3/7, and this is, it's 2, so you're going to have 4/7 left. And it's negative because that's negative. So what is my equation? My equation then becomes y equals my slope, which we found earlier was negative 2/7, negative 2/7 x plus negative 4/7. Someone asked me yesterday, can my y-intercept be something other than a whole number? And I said, of course it can. Okay, so we have plus, still don't like that, plus negative 4/7. Now we're on to number 10. We're asked to write an equation in slope-intercept form. So we know that is y equals mx plus b. We want it to pass through the given point, and we want it to be parallel to this line. Okay? Well, we know if it's parallel, it has the same slope, right? So if this slope is negative 1/2, we need a slope of negative 1/2 that goes through the point negative 3,5. So it's going to be this line that we create out of this point and this slope will be parallel to this line right here. Okay? So in order to write an equation in slope-intercept form, we could either find B, since we already have M. I'm going to show you an easier way, and a lot of people thought today, oh, why didn't I think of that? Okay. Could I use point-slope form? Sure. Yeah, the point and the slope. Okay? And it actually, I think, most times, if not all the time, is easier. So I can distribute y minus 5 equals negative 1/2 x plus a negative 3/2. And then I add 5 to both sides. And I get y equals negative 1/2 x. And this is negative 1.5 plus 5, which is 3.5. Is that in slope-intercept form?
Yeah.
Done. Pretty cool, huh? That was, now you could find B and do it that way as well. Number 11 is exactly like 10, except we want it perpendicular. And we know if this slope is 4, then we know the perpendicular slope is going to be opposite reciprocal. Opposite of positive is negative, reciprocal of 4 is 1/4. So now I just need a line that goes through 5, negative 1, and has a slope of negative 1/4. Do you want to do it the same way we just did, or do you want to do it by finding the B the other way? Okay, the other way. So the other way, we could plug in into y equals mx plus b. We can plug in for y, our y coordinate that's on the line. We can plug in for m. We can plug in for x, the x coordinate that is on the line. And then we can just simplify and solve for b, which we've done in class quite a bit. We get negative 1 equals negative 5/4 plus b. Add 5/4 or 1 1/4 to both sides. And we get b equals negative 1 plus 1 1/4 is 1/4. Okay? So then we get y equals, what is my slope?
Negative 1.
Negative 1/4. Okay? So, you get to choose which way you like better. I think point slope so So a lot of times, see, we learned this before we learned point slope, and now we have more options. So you just have to decide which one to use, and realize that you can use more than one option. And that's important. In math, that's a lot of what we do is we learn multiple ways, and then we get to pick the way that makes the most sense to us. Okay, moving on, number 12. The key on 12 is to read the directions. It's a proportional relationship, which is another word for what?
Direct variation.
Direct variation, good. Jolie, direct variation. And we know when it's a direct variation, what two things are always true?
It goes through the origin and the ratios are always equal.
Okay, it goes through the origin and the ratios are always equal. So that means that I can find k if it's proportional. And k is always y over x. Oh, so my constant, just like slope, is going to be 15 over 6, or 2.5. So my equation is y equals kx, or y equals 2.5x. Why is there no intercept? Well, there is an intercept, it's just 0, so when we simplify, we don't have it there. Right? Direct variation, proportional relationships. Pretty basic. Okay, so that's the answer to number 12. Number 13, does the data represent a proportional relationship or direct variation? And if it does, write an equation. So I know what Cameron just said is y over x should equal y over x in every case if it is a direct variation, correct? And what do these all simplify to be? So is it proportional?
Yeah.
What's k?
6.5.
Oh, really? Is that it? That's all? 14. We need to put that into standard form. I'm going to create a little workspace here. I saw some of you had this wrong. Okay? Standard form, which is in your notes. You guys need to really make sure you use your toolkits. You might want to take some Post-it notes, make some, tags so you know where to go to find things. Okay? But if I need to put it in this form and it's in slope-intercept form, I can just apply my algebra skills, properties of equality, and get x and y on the same side. I'm just going to, there's lots of different ways we could go about this, but I'm going to go negative 7/8x plus y equals 10. Okay, I also know in standard form, the coefficient of x cannot be negative and it cannot be a fraction. So if I multiply both sides by negative 8, this is going to make 7x. Then I do a negative 8 times that, so it'll be plus a negative 8y equals, and I must do it on both sides, negative 80. Is A positive? Yep. B and C are integers, and so therefore there are no fractions. I'm good to go. That's standard form.
Yeah.
Yeah! That's what I'm talking about. Okay. Number 15. Okay. These ones I like because I thought they were a nice break, pretty simple. I just need to find the slope. What's the slope of the top one? Okay, can I find the slope yet on this one? No, I need to get y alone so I can find my slope. So I just have to, this is back to the very first unit we did of the year. Applying properties of equality. Yeah, I knew there was a reason we learned that. So this is one thing I saw students make a mistake on this morning. They forgot that when you have a quantity divided by something, it's the whole quantity divided by that. So it's y equals 10 over negative 4, or negative 2.5x, plus negative 1/2. Or it could be negative 5/2 x, which is actually probably better, plus negative 1/2. But they're both right. Okay, so since they do have the same slope, they are parallel. Okay, so that one would be parallel. 15, parallel. Okay, so 16, if we get y alone, this one they gave it to us. Nice. I only have to get y alone for the second one. I can subtract 12x and get 16y equals negative 12x plus 4. I do the negative 12x first, so it's already in slope-intercept form. And then I can divide by 16. And again, I have to do both divided by 16. And I get y equals negative 3/4 x plus 1/4. Are those opposite reciprocals? Is that an opposite reciprocal of that?
No.
Or this? Nope, they're opposite, but they're not reciprocal. So don't get fooled. That's a neither. Okay? Then, when we look at the last one, you're probably thinking, it's probably perpendicular because we got a parallel and a neither, right? That would make sense. Let's find out. So, I was given the slope on this one, so I don't have to work hard at that. On this one, I have to get y alone. So I better be good at getting y alone by now, right? And divide by 2, and y equals negative 3x minus 3. Is this and this, my slope of my other line, are these opposite signs and reciprocals?
Yeah.
Oh, that means they're perpendicular. So far, so good. Not too bad, right? Okay, the scatter plot. Someone today, and these are great to learn from these mistakes now versus on the test. When I look at this, I see this line going through 2 points. I see it going through that, and I see it going through that. I see it close to a lot of other points, but it's only going through 2 points. So does that mean I need to use those 2 points to write my equation?
Yeah.
Yes. Some people use points off of the line to write the equation. That doesn't make sense. If that's the case, I need to change where my line goes, because I'm writing an equation of this line right here. So if I'm writing an equation of that line, I need to use 2 points on the line to write that equation. Okay? So what are those points? 6, 55, and 12, 40. Can I write an equation of a line through 2 points? Of course I can. We've been doing that a ton. So all I do is I need to find the what? Slope. Good answer. I'm glad you all shouted that out at once because you all knew it. Okay? And then I get negative 15 over 6, which is negative 2.5, or negative 5 over 2. Thank you. And then I can do the point slope way, like I showed you. A lot of you agreed that's easier. So I have y minus 55 equals negative 2.5 times x minus 6. Distribute, and I get y minus 55 equals negative 2.5x plus 15. And I add 55 to both sides, and I get y equals negative 2.5x plus 70. Okay? Makes sense, right? I mean, that's my line. Why do I want an equation for my line? Well, so I can do exactly what it asked us to do on the following equations. So that was y equals negative 2.5x plus 70. Is that what we had? Plus 70, yes. Okay, so we're going to use that for the rest of this. Okay? So let's get rid of that. Oh, that was unfortunate. All right, so how many mistakes would you expect the student to make if they practice 20 hours? Well, can't I just plug this 20 in there and get y equals negative 2.5 times 20 plus 70? And what do I get? 20. So I get 20 mistakes for 20 hours. Okay? And then, how many would you expect that student practice if they made 50 mistakes? That's a lot of mistakes, right? So probably not a lot of practice. So what's 50? X or Y? Y. So then I just go like this. I'm going to use 50 equals, so I'm going to plug in 50 for Y, and then equals negative 2.5x plus 70. And I'm going to solve for x. So I get pretty simple here. I just subtract 70, and I get negative 20 equals negative 2.5x. Divide by negative 2.5, and x is 8. I could look at the graph. Okay? So 8. 8 what? Hours. Okay? Make sure you label correctly because it's not 8 mistakes. I made 50 mistakes. Okay? And Jolie made a good point. If I look at 8 hours, where does it cross the graph? The only thing is, yeah, it does, right there at 50. And at 20, the first one was 20 hours. That one we had to extrapolate, therefore we had to use the equation. Okay? That was extrapolation. This one was extrapolation, because we had to go out to 20 and go, okay, well, if we extend this out here, what's it going to be? So that's extrapolation. All right. Moving on. What kind of correlation does this graph have? What does it look like? Negative. Because one goes up, the other goes down. So that's why I wrote it's a negative correlation. It is causal. Well, negative correlation because as what? As number of hours. Yeah, but I like to use when we talk about graphs and real life situations. I like to use that just so we can connect it. As number of hours increases, I'm going to write that out. I was going to put an arrow, but as the number of hours increases, the number of mistakes decreases. Okay? Is it causal? Does it make sense that if you practice more, you make fewer mistakes? Totally. Just like in math, If I practice more, I expect to make fewer mistakes. Really? True story. Okay, 23. Table shows amount of money earned. Someone came up to me yesterday and said this isn't a direct variation, it doesn't work. But what do the directions say? Write an equation in slope-intercept form. So I can't emphasize enough to read the directions. Read and understand the question before you jump into it. Okay? Is there a constant rate of change?
Yes.
Sure. As this is going up 51, this is going up by 3. As this goes up by 102, this goes up by 6. But the slope is always what? 17. Okay? We could write these as ordered pairs to find that slope if we want it. Okay? 9, 207. And then I could get the slope of 207 minus 56, 156 over 9 minus 6, which gives me 51 over 3, which is 17. That's my x. And then this is kind of cool. If you look at the table, look at what I could do if I went back in the table. If I went back to 3 hours, what would I go back to in money earned? I'd subtract 51, right? Because if I'm adding 51, wouldn't I go backwards and subtract 51? And if I went back to 0, what would I do to 105? Subtract 51 again? Great answer.
Welcome.
I didn't think this was a tough question.
You're welcome.
What, am I thinking myself? All right, so what's the y-intercept? Or you could have put it in point slope form and figured it out as well. Okay, all right, glad we had that chat. All right, 24. So we need to write an equation in standard form where we're going to use DVDs D and video games G. We want to figure out how many we can rent for $20. So if I pay $4 per DVD and they've defined the variables for us, $2 per video game, and I'm going to spend $20, does that represent my standard form of that equation? Yes. Now if I look at, okay, well how many could I buy of each? Well, let's think of D and G. Okay, what if I bought 0 DVDs? How many games could I buy? 10. What if I bought 1? That would be 20 minus 4 is 16. It would be 8. What if I bought 2? This would be 8. You get 2G equals 12. That would be 6. And we can see that there's a pattern. This would go 3, 4, 4. Follow the pattern. 2, thank you. And 5, 0. So you could buy 5 DVDs and no games, no DVDs and 10 games, or some combinations of each. So those are 6 of the possible. You only need 3 answers. Those are 6 of them. The only 6. All right, we're going to get there. Okay, 26. Write the slope-intercept form, and there's a very important hint here. So if you tried to take a shortcut, you probably got it wrong. Okay? Now, is the slope hard? -3, positive 1, 2, 3, 4, 5. -3/5. Right? Everybody see that? Slope's -3/5. Okay? How am I going to find the y-intercept? Yeah, I'm going to use point slope form because I think it's easier. So if I know it goes through 3, it looks like it's like -1/5, I would say. But I don't know. I want to make sure. So I want to make sure I'm right. So I'm going to plug into point slope form. So let me go ahead and put another workspace up here. And y minus y equals m times x minus x. Plus a positive distributes. Y plus 2 equals -3/5 x plus 9/5. And then I just have to subtract 2 from both sides. And y equals -3/5 x plus a -1/5. Because that's 1 4/5 plus the -2 is -1/5. Good? Okay. And again, please go on YouTube if you want. You can pause it whenever you want and really figure things out if you want to go a little slower. 27, the average daily winter temperature in your heating bill. What happens as the temperature goes up?
Your heating goes down.
Right. So as the temperature goes up, your bill's going to go down.
They're not going to use as much heat when it goes
Okay.
hotter out.
But it's just winter.
But we're going to use
Okay, so we're in the winter, and in the winter right now the temperature's going up, right? It's supposed to be 55 today. Okay? I'm not going to get charged for heat because my heat's not going to kick on at home. When it was 20, my heat was kicking on all the time, and so I paid a lot for it. So as the temperature increases, the bill, my Avista bill is decreasing. Again, that would be a scatter plot. Right, but so exactly. So this would be a perfect scatter plot situation. You plot every day what the temperature was, how much heat you used, and then we can make a trend line, and we can figure it out. Because it's not perfectly linear. You're right. It would go up and down. Okay, but in general, there would be a correlation, and it is causal. Okay, the bonus. I really like this bonus because you guys had to think a little bit, but it was doable. We have a line, y equals negative 4x plus 4. What is the slope of that line? Okay, negative 4. The x is not part of the slope. Okay, and we also have a line that is parallel. Okay, so we have a line that is parallel, and its equation is 2y equals kx plus 9. So what's its slope? I don't know yet. I have to get y alone. So y equals k over 2x plus 9 halves or 4.5. Right? Right. I mean, it's just a k. That's what's kind of funky. But that's just a number. So the question is, what value of k would make these perpendicular? So what do I need negative 4 to be? What do I need my slope down here to be for them to be perpendicular? 1/4. So I need k over 2 to equal 1/4. Right? Don't I need this right here to equal the opposite reciprocal of 1/4?
Okay.
So I can multiply both sides by 2 and get k equals 1/2.
Why? Wouldn't it be negative?
No.
No.
Nope. Okay. From what? And then.
You said I answered negative 8.
Okay. I accidentally just did the perpendicular one first, so that's the second question. Sorry. Yes, my fault.
You put negative 1. Yeah.
Oh.
Yeah, and negative 1.
Okay. Now let's take a look at the bonus. So first thing I'm going to do is make sure I understand the question. I can get 1% times 4 or 4% added on to my test score at the end. So first thing I have to do is find a value of k that would make these two graphs, this one parallel to this one right here. Okay? I have to do the same thing if they're perpendicular. Then I also have to talk about proportional relationships and what makes those different from just a regular linear equation that is not proportional or a direct variation. Okay, so let's work on the first one. The line that I'm given is negative 4x plus 4. Okay? And if I want something that's parallel, I want a slope of negative 4. If I want something that's perpendicular, I want something with a slope of 1/4. So opposite sign of negative is positive, reciprocal 1/4. Okay, now that I've established that, I need to do some work with this second equation. I know that it's 2y equals kx plus 9. So I need to see what that would be in slope-intercept form. So I'm going to divide by 2, and I'm going to get y equals k over 2x plus 9 halves or 4.5 when I go ahead and reduce by looping. Okay? So then what I realize is this isn't so bad now that I've figured this out, because now I know that k over 2, or my slope of this equation, has to be, if it's parallel, has to be negative 4. So I can simply go k over 2 is negative 4, and I can multiply both sides by 2 to solve that, and get k equals negative 8. So in order for these to be parallel, k must be negative 8. Okay, that's the first bonus question. The second one is, what do they need to be perpendicular? So instead now, my equation becomes k over 2. It's still k over 2 is my slope, but I need it, instead to be negative 4, I need it to be 1/4. So again, I multiply both sides by 2, and I would get that k equals 2/4 or 1/2. So 1/2 would give me the correct slope on that to make that line perpendicular. So there's my first 2 points of my bonus. Okay. The third one can be found by telling what makes a proportional relationship different from a linear relationship that is not proportional. So the first thing that makes it different is a proportional relationship always goes through the origin or 0, 0. Okay, the second thing that makes them different is proportional relationships, the ratio of y to x is always equal. Okay, and those are the 2 extra points you could have gotten, and therefore you could have gotten 4% out of your test. Hope that helps. Go ahead and watch this video again, pause where you need it, and of course come in if you have questions. Good luck studying.